Good morning, sir.
Good morning. Right, Ramanand, we start the class.
Yes, sir. Start it.
All right. A very good morning to all of you. I hope everybody is fine and staying at home. Continue with our class. I believe this is our fifth or sixth class. Ramanand, you're recording it, right?
Yes, sir. It is our
Okay.
sixth class.
What? Sixth class. Okay. What we have started in our previous class was regarding the layering, the protocol layers and the service models. Ramanand, is the PPT visible?
Yes, sir. Chapter 1. Now protocol layers.
Layers and reference. Okay. I'll stop the video so that we save upon the bandwidth. Okay. Now, like I said in the previous class, that this is the main aspect of computer networks. This is we are going to actually study for the rest of the course. That is the OSI layering. First, we took out the example of the airlines to understand why there are, why we need the layering. We saw how airlines is horizontally divided into different layers in order to firstly find out where is the problem. Like I gave an example that if your baggage is left somewhere or lost, you will not go to the pilot, you will not go to the ticketing place, you will go to the concerned place. So this was what we had, the horizontal layering of airlines. Likewise, we have layering of uh, computer networks. Why? In layering, we'll say each layer would have its own functions. There is a list of advantages that we have. Let me just see if I can. I need to stop share to use a whiteboard, is it? Let's see. Yeah. Okay. So we are here discussing certain advantages of layered architecture. The first one that I'll be taking is about flexibility, maintainability, and scalability. Well, the terms, each one has its own meanings. If we have layered architecture, it will make it more scalable. And what do we say scalable here? It would be easy for us to expand the network. It will be easy for us to maintain the network, and the network would be flexible. Maintenance in the sense that if you have some issue with your network, by knowing that this issue pertains to this layer, this protocol may be involved or this hardware may be involved. The second advantage that we have is we can test components independently. The third advantage that we have is we can have applications independently deployed. maintained and updated, and also on different time schedules. And also it will help us to accommodate different users. Like for example, if one is speaking one language, another is speaking another language, by having these kind of architecture, layered architecture, this will help us in communication. Also, this will help us in security and privacy. This is a list of advantages that we have because of the layered architecture. And once we have this layered architecture, based on this, we have two reference models. We call them as reference model. And what are these reference models? The first one is known as OSI. Actually, it's ISO OSI reference model, wherein ISO stands for International Standards Organization. OSI stands for Open Systems Interconnection. So it's International Standards Organization, Open Systems Interconnection Reference Model. In short, we call it as OSI model. The second one is TCP IP reference model. Now, TCP IP reference model has a lesser number of layers, and ISO OSI has 7 layers. So we would take OSI reference model to understand better. In short, we'll be calling it as OSI model. And OSI has 7 layers. How do we actually make these layers? You say that each layer, the designer said that each layer should have a certain type of abstraction needed. Well, you took this word abstraction in, I think, almost all courses. You saw abstraction in OOPS, you saw abstraction in OS. And here also we have an abstraction, a certain level of abstraction. That is, one of the layer would cover the functions that a layer below would have. The second thing that we come across while arriving at these 7 layers is that each layer should perform a well-defined function. The functions that each layer should do would be based upon some of the internationally standardized protocols. In the sense that if I have 2 layers here, I have some protocols. I would place some protocol in one layer and some protocol in another layer. And the size of the layer should be such that it should not be that big that you cannot have distinction between different layers, and it should not be that small that all the protocols cannot be covered within it. So based on this, we have the OSI reference model. I'll go back to the PPT. This is while layering Internet protocol. Let me go to the see, I need to go to the last one where we have here. Ramanand, are we on ISO OSI reference model slide?
Yes, sir. ISO as a reference. Presentation session.
Okay. So this is how the OSI reference model would look like. It has 7 layers. We'll go from physical layer, then link network transport session, and at the last we'll take up the application layer. This approach is known as bottom-up approach. Your book Kuros says top to down approach, means it will start from application, presentation, session, transport, network, link, and physical layer. Now, a little bit, overview of what each layer is supposed to do. The first layer, that is, how do we actually remember these? We need to remember the order of it. L1 is the first layer, that is the physical layer. There is a short form. In fact, this short form, your book would also say. Anybody knows this short form? All people seem to need data processing. All people seem to need data processing. You get from here, from the top: application, presentation, session, transport, network, link, and physical. Actually, link is data link layer. That's why I need data processing. All people seem to need data processing. The link is data link layer. So go to the layer one, that is the first layer, that is the physical layer. So what do we see here in the physical layer? It is concerned basically with transmitting over a physical channel. So it is basically the first layer that the link would connect to. It is concerned with one sending as one, zero sent as zero. So basically it would deal with the design issues of the network. It will take care of, electrical parts, the mechanical parts, the interfaces that we have, the physical transmission that we have. So all the links that we have below, whether it's wired, whether it's wireless, would first interact with the physical layer. For example, if we are talking about electrical part, we have to take care of whether this, uh, you know, zero is represented as zero or one is represented as one. Means the voltage by which one is supposed to represent, let's say plus 5 and minus 5, whether we are getting plus 5 and minus 5. So physical layer would be concerned with this. Ramanand, can you take the attendance?
Yes, sir.
Okay, thank you. So this is what the physical layer or the first layer would be doing. The second layer that we have is known as data link layer. So obviously, what data link layer does, as per the service model which we discussed in our previous class, data link layer would take data from network layer and pass on to the physical layer after doing some work on it. So this can be the way when you send the data from A to B. When B receives it, physical layer first receives from A, and then data link layer passes this data from physical layer to the network layer. That is the service model that we discussed in the previous class. And what function does a data link do? Now, there are several functions that data link does. One of the functions that data link layer does is it will check for errors, whether there are any errors in the packet that has been transmitted or not, like transmission errors can be there and so on. It ensures that frames are sequentially sent. It will take care of that as well. And then it can give acknowledgements as well based on, frames sent by the receiver. Moving on to the third layer, that is the network layer, one of the important layers. So network layer would be in between the transport and link layer. It is known as layer 3, L3. There are three main functions of network layer. One is addressing. When we talk about IP address and so on, this will be discussed within the network layer. Sending of packet from one end to another, that is what we know as routing. It will be taken care by the network layer. Determining destination, how your packet would be routed from source to destination. Whether route is a permanent or a dynamic route, what we call a static route or dynamic route. and so on, taking care of congestions and so on, counting functions, uh, connectivity function. This is all done by the transport layer. Then we move, sorry, network layer. Then we move to the transport layer, that is the layer 4. The function of the transport layer would be like accepting data from the session layer from one end, or the other end, it will accept the data from the network layer. It can, once transport layer gets data from session layer, it can break up the message into smaller units if it's required. Then it would pass it to the network layer. It would ensure that all the pieces are you know received at the other end correctly. It will take care of error free transmission as well. It will take care of in order delivery, means if it's like out of order, it will bring all of them in order and pass on to the session layer. Certain other functions like flow control can be implemented by transport layer as well. Then we have session and presentation layer. They are often known as to be optional layers as well. That's why we will see that in TCP IP, these two layers have been combined together and put it in one layer. We have that's why
మమ్మీ
number of
గిన్నెలో
layers
నీళ్ళు
as
తీసుకురా
lesser.
చేయి కడుక్కున్నాను.
Certain functions like establishing of sessions between the two nodes can be done by the session layer. Login to remote systems like remote logins can be done by session layer. Dialog management
ఆ
is
డోర్
done by
వేసేరా.
then session layer, token management, as well as synchronization. Presentation layer mostly concerned with syntax and semantics of information that is being transmitted. Like for example, if you have certain type of encoding, presentation layer would take care of that. And the last one is the application layer. Application layer is the main layer which takes care of data from the application. If you have a running application, it would take data from running application and then pass on to the protocol stack. That is what we have here as the 7 layers. A variety of protocols that you would have used, STP, email, FTP, and so on,
ఏంటన్నా ఎవరం
are
కొడుతుండ్రు.
part of the application layer.
ఆడు లేడా.
This is just a brief overview. Now, what we are going to do is in coming classes, we will be taking each layer one by one. Now, what does a layer do? Let's see. Okay, here. Now, each layer has been given a specific function to do. Now, here you will see only 5 layers. When we have 5 layers, this is the TCP IP reference model. Now, we are discussing data transmission in the TCP reference model, in which we have a source that is at the top and destination at the bottom. Source receives M message. So this is our packet, what we have received at the application layer. And what does application layer do? It does its function. It does certain, it implements certain protocols to it. And where is the information about those protocols kept? Inside the header, what we called as overhead in the last class. And that overhead is added to it. You can see M moved to the transport layer. And what M had with it? M had a header added to it known as HT. Actually, there would be a header of application layer as well. So we have a header here. When it moved to the network layer would do its own functions. Like for example, the source address, IP address, the source destination address. This is to be given to the router where you can find the path of it. So this would be added as a header of the networking layer and then passed on to the link layer. Link layer has its own functions like error checking and so on. Like for example, if CRC is to be done, the information about that is to be kept in the header of the link layer. And then this is passed to the physical layer. The physical layer through the wire that is of the red color passes on to the switch. Here we have a node which is known as a switch, which has only two layers available, that is physical and data link layer. So what would switch see? Switch would see only up to the header of the data link layer that has been put. Then it moves on to the router. You can see within the router there are three layers available: the physical, the link, and the third one is the network layer, which also means that the this packet can be opened up to network layer by the router. And within this network layer, what was the information that we had kept? We had kept the information that uh, destination address is this, source address is this. And how would the router know where to forward it? Based on these addresses. So router can open this packet up to the network layer. Beyond this, what was kept as a header by the transport layer or the application layer or session layer or presentation layer, router cannot see that. For it, the rest is data that it's transmitting. So it would check the destination. Based on the destination, it would route it. So we would have the packet moving from the router, from the network, and it goes to the destination, which is taken by the physical layer. Physical layer gives it to the data link layer. Here, data link layer can open the HL, that is the first header that we have within the packet, and passes on. After opening the header, it sees what, for example, error checking has been done. The data is given here. It removes that part, the header of the data link layer, gives the rest to the network. Here you have to see one thing. The network layer would basically look at the header of the network layer. It won't be concerned with the header of the transport layer. It would check whatever it has to do, the functions it would do, remove the header of the network layer and pass the rest to the transport layer. Again, transport layer would look at the header of the transport layer HT, remove it, see what the function is supposed to do based on the information that is given in the header, pass it to the application layer, and application gives this to the destination application. So if it was, let's say, Facebook Messenger, application layer would pass this data within the packet M to the Facebook Messenger of the destination. Is this part clear? So each layer would have some function to be done, and this data or this header would have the information about that function. This process is repeated for each and every packet that is to be sent through this transmission medium. You saw here there are 5 layers. This is the second reference model, that is TCP IP reference model. This reference model is used by ARPANET. And what was ARPANET? When we took the history of it, it's the grandparent of all computer networks. The first, network that connected hundreds of universities and government institutions across United States using the telephone. That was the leased line. But TCP/IP does not define clearly with regards to presentation layer and session layer. That's why we use OSI. This TCP/IP reference model has several names, like a DoD model, that is Department of Defense model. It can be also named as Internet model, given by Winton Cerf and Robert Kahan in 1974. This TCP/IP reference model. Why it is named as TCP/IP reference model? TCP is a protocol of transport layer. IP is a protocol of network layer. They are so important in this model that the model itself has got the name as TCP/IP reference model. Some models will give you only 4 layers as well. Now we would, I mean, there are different terminologies that TCP/IP would mention. Rather than network layer, TCP/IP would say internet layer, the another name for it. With the functions would be just the same. For the physical layer that is given there, it can, uh, if we take TCP/IP, let's say we'll take 4 layers. Instead of physical layer, we would have host to host layer. Then we will have internet layer. Then we'll have transport layer, and then we will have application layer. These would be the 4 layers. Anyhow, since we are taking the OSI reference model, so we would go ahead and start with the OSI reference model. A good comparison between OSI and TCP/IP reference model would help you to understand the differences between the two. And it's not just that we have only these two models. There are several other example network models as well. Like one of the examples that your book might also have is Novell's NetWare. It was the popular network system in the PC world, that Novell NetWare. It was for those companies who changed from mainframe to network of PCs based on a client server model. It had its own protocol stack. When I say own protocol stack, means it was a proprietary model. It was not like open systems interface. Like OSI says, I'm open to all the devices that are, open to communication. But here, it was based on the Xerox network system, XNS, old Xerox system network. And these were for companies, that would use this type of network only, the proprietary system. Now, what were the differences? They had its own layering, like it had 5 layers. The network layer would have protocols like IPX, which stands for Internet Packet Exchange. Like we have here IP in network layer, Internet Protocol. It had Packet Exchange. Transport has NCP and SPX, and so on. There were other protocols within it. You can go through ARPANET and check how it looked like. Another one was US National Science Foundation's NSF-NET. Look at that as well. There are pretty good internet test beds, which were known as gigabit test beds, like of MIT and University of Pennsylvania and IBM's Aurora. There's the Blanca, Casa, and so on. Okay, the next part of our lecture, we'll start with the physical layer. Do I have any questions? Also, another thing that we need to do is we need to complete our lab. There were some slides which we left within the lab as well. I'll take 15 more minutes and then we'll continue with our lab. The physical layer. Let me go back to the whiteboard. So this is our first one. This is known as layer 1, and this is the physical layer. This is the layer which is responsible to communicate with a link. How would it look like? Let me draw it. I have a system A, I have a system B. They are two nodes. What are nodes? For those who haven't seen the previous videos, nodes are any devices which have the processing capabilities. They would have some memory, they would have some processor, and so on. They would have these processing capabilities. All right, this is the communication between A and B. Now, I have an application that is running here. This is, for example, a Facebook Messenger. And I have written here within this message, I, and this is supposed to reach to B. So obviously, if I use the model, I would have it passing through it, moving across this link and reaching to B and moving up. And here I would have the similar application which would be receiving it. That is Facebook Messenger. And what would I get inside? I will get this I, right? But coming to the point where we discuss that each of this has a different layer, 7 layers. And what we are discussing is the first layer, that is the physical layer, that is somewhere here. That is the first. So I would enlarge it and take the basic layer here. This is my layer 1, that is L1. So what does this layer 1 or the physical layer do? It takes the data from the higher layer, okay, and then what it does with it? Does something and passes on to the physical link. So this layer that I have here is responsible to transmit the data after doing its functions. So if this was the data I have received, if this is I have packet I have received, fine. What would the layer 1 do? It would add its own functions, fine. Then what? After doing that, it would add the header to this and pass on to the physical layer. So L1 is an interface between this link that we have here and the above layers. The term that we use for physical layer is PHY in short, or layer 1, and it provides basic hardware transmission technologies. Now it is one of the big layers because it is very complex in OSI. It has a lot of functions to do with respect to numerous types of devices that come across. It would basically define means of transmitting raw bits. When we say raw bits, it's not concerned with what the meaning of these bits would have. It's concerned with I have to send this as 01000000. This would be my packet. So its main concern is this. So by definition, physical layer would define a means of transmitting raw bits over physical link connecting the network nodes. So how would it transmit these zeros and ones? The physical layer would have a connection here. At this point, there would be a connection which I have marked here. This is known as an interface between the device, that is the node, and an interface between the link, what we see as a network interface card. And when it transmits and receives the data through this interface, what it basically does. What is this 1 and 0? It is an electrical impulse that it is. So bit stream is converted into a physical stream, a physical signal that is transmitted over the link through an interface, through a transmission medium. Transmission medium can be wired, transmission medium can be wireless. If it's wired, like here I have a link, it's connected to an interface wherein I have these zeros and ones sent as electrical impulses. It can be transmission through a fiber wherein these bit streams are sent through light pulses. It can be through the waves for wireless transmission through air and so on. So all of these are taken care by the physical layer. These functions are taken by the function layer. Let us take the functions of physical layer one by one. The first function that we come across. So functions, services, and functions of physical layer. Mohammad, am I visible? Whiteboard is visible?
No, sir. It will take some 5 to 10 seconds. No problem. You can continue.
What are you seeing this time?
It's blank whiteboard. Ah, now it's visible.
Oh,
Some 5 seconds delay that.
how about others?
For others also same, sir. 5
Okay,
seconds delay, that's it.
okay, blank, okay, visible. Okay, there's a little delay. Fine, fine. I understand. Then I would have to accordingly, you know, take some time while explaining it. A lot of time to update. Okay, fine. I understand there is some delay within the video, so I will go slowly then. The services and functions of physical layer. The physical layer has a sub-layer which is known as physical signaling sub-layer. And that physical layer basically interacts with a higher layer. I will draw this layer to understand it. This is data link layer, I will say in short DLL, and this is the physical layer. I'll go a bit slowly so that everybody can catch it. Okay. Now, within this, right, I have these drawn now. The above one is the data link layer, that is the layer 2. The lower one is the physical layer. And the two here would have two sub-layers. One is known as the MAC sub-layer, where MAC is the medium access control sub-layer, and the physical layer would have the right here sublayer. This is known as physical signaling sublayer. Now these two sublayers communicate with each other, the one from the physical layer and the second from the link layer. Now coming to the major function here. The first function that we come across is bit by bit or symbol by symbol delivery. So when A and B are connected to each other through a link, the delivery from A to B, sending these bits as ones and zeros, is done by the physical layer. It is responsible for this bit by bit or symbol by symbol delivery. This is also known as, you might have studied in datacom, as symbol rate. There is another name for symbol rate. Can anybody tell me? Faster. Symbol rate is also known as good. Baud rate. Nawazish. I'll give you +1 for that. Nawazish has replied it. It's also known as baud rate. +1. Okay. Then it's also known as modulation rate. Arifa, you are also correct. Okay, I'll give you also a point. It is baud rate or modulation rate. Both are correct. Both of you would get a point. And what basically it is, what this symbol rate or baud rate is, it's number of symbol changes, or also known as signaling events, made to the transmission medium per second using a digitally modulated signal. This is the first function that we have. The second function that we have is providing standardized interface to physical transmission medium. What we mean by interface? All of you are using a laptop or a desktop or a mobile phone. Okay. If you are wirelessly connected, there is a card within your laptop, which is a Wi-Fi card, which helps you connect to the Wi-Fi router. If you are connected by a wire, there would be a point wherein you would have plugged your wire into the laptop or desktop. That place where you have plugged in the wire, let's say through RJ45 connector, that is what we have as an interface, which we know as an network interface card or NIC. Now, how much would be the size of this interface? Which specific wire would get connected to it? Like we say Cat6, Cat5. This we would have taken in our lab 1 when we would have done crimping and so on. This will take once you are back, inshallah. How much should be the, signal in volts for the transmission of bits and so on? If you are using wireless, what should be the electromagnetic spectrum frequency allocation? How much should be the signal strength, bandwidth, and so on? These are all taken care by the physical physical layer. So within these providing standardized, when I say standardized interface, it is standardized world over. You say RJ45 is a connector, the same size, the same specification, the same way of crimping is done by everybody. So this standardization firstly would have mechanical specification. Specification of what? Electric connectors, cables, and so on. I just now mentioned the electrical connector. I just now mentioned the RJ45 connector. Uh, uh, if you've seen how RJ45 connector looks like, let me just put up a link here so that you can just go there. Okay, I have here one. I'll just let me just share one. Okay, can you see this, Ramanand?
Yes, sir. Yes, sir.
Okay, fine. So this is what I'm talking about, RJ45 connector. It has 8 lines, what we call as 4 pair of lines connecting to it. And this RJ45 connector is placed into interface within our PC. And when we have the size of it, the specification for it, this is a connector for us. Back to the okay. I'm back in the whiteboard.
Yes, sir.
Okay. Then I have cables also. There is a cable, whether I use RJ for whether I use Cat 6 cable, presently what we are using like Cat 6C, whether I use Cat 5 cable, the difference between these cables is the transmission capability, the strength, so on. How far can I transmit using this Cat 6 cable without having a signal loss? This is what we have in mechanical specifications. Then I have here electrical specifications as well. Actually, mechanical specification, when I talk about cable, I would talk about the length of the cable. When I talk about electrical specification, I will say transmission line signal level as an example. Transmission line signal level. What would be the impedance within that link and so on? This is what we have as electrical specification. Then interfaces that we have, like radio interfaces or network interface card NIC that we see. If we're talking about radio interface, within this radio interface interface, what would be the signal strength here? What is the signal strength of it? What is the bandwidth? Analog, digital, and so on is taken care of it. Whether it's over fiber, whether it's over infrared, whether it's Bluetooth, what type of communication it is, it's taken by the physical layer. Then I have the third function. And the third function that I have is modulation. Again, this would be covered in datacom. And what is basically modulation? Modulation is you convey one signal over another signal, a process in which a message signal is conveyed over another physically transmitted signal. You might have studied, in which waveform is used to transform a baseband message to a passband. For example, we have RF signal, a radio frequency signal. This modulation is done by the physical layer. Then we have line coding. Line coding, also known as digital baseband modulation, again taken care by the data communication. You might have studied that there. This is used for baseband transmission. Typically, when you study about digital data transport, line coding is used for digital data transport. And what is basically line coding here? You choose a specific pattern of voltages which would be used to transmit a binary, which would be used to represent binary digits on a transmission medium. In this line coding also you would have to take care about bit no, we'll take that separately. I hope you get this line coding here. You would have studied this line coding. We have bit synchronization. I'm moving it faster because this all modulation, line coding, synchronization, this would be taken care by datacom. Bit synchronization is used in synchronous serial communication. What it is basically? It's determining the boundary, the start and the end of a signal. How do you say that this is a bit? Start of the signal, or you might have studied this as clock sync as well. Bit synchronization or clock synchronization. This synchronization is between the source and the receiver to ensure that the signal is rightly decoded by the receiver. The signal is rightly understood by the receiver that yes, this is the start of the signal, this is the end of the signal. Number 6, we have the concept of start-stop signaling. This is done by the physical layer. This start-stop signaling is used in asynchronous serial communication, whereas bit synchronization is used in synchronous serial communication. Both of them have this responsibility to ensure that the signal is rightly decoded by the receiver, to ensure that it understands that this is the bit, this is the signal, start of the signal, and this is the stop of the multiplexing is done by the physical layer. What is multiplexing? You would be quite aware of it. That Multiplexing would be a method by which we can have many analog signals combined together and sent over a common shared medium. Circuit switching, the physical circuit switching, responsibility of the physical layer. And some part of the functions in which we will study in MAC sublayer of data link layer, that there is carrier sensing as well as collision detection. This physical layer helps in sensing as well as collision detection for MAC sublayer. Some error correction, a part of error correction is also done by physical layer, which is known as forward error correction. An example of FEC, that is forward error correction, is bitwise convolutional coding, in which it checks whether bit the bits that has been received have been correctly received or not. We saw a configuration. These were the basic functions that we have. Other things also in which the physical layer is concerned is the topologies. The physical network topologies that we came across are concerned are the concern of physical layer. Whether you have a connection that is P to P, what is P to P? Point to point. Whether it's multi-point, whether it's point to multi-point. This is concern of the physical layer. If you're talking about physical topologies like bus, ring, mesh, star, hybrid tree, and so on that we studied in the previous class, this is again the concern of physical layer. Number 11, whether the network is doing serial communication or it's doing parallel communication, it is the concern of physical layer. Number 12, you understand what is serial and parallel communication? Okay, fine. No? You understand serial parallel? Let me take a little moment to make you understand the serial and parallel communication. This would help us. Two things I will explain here. For modulation, line coding, bits, have you studied this in Datacom? Okay, good. Then I won't take a bit time here. I'll take a little, data communication is parallel, serial can be synchronous, asynchronous. No? Okay, let me take a little while to explain this. So if we talk about data communication here, data communication can be branched into two. One is known as parallel. The second is known as serial. And then serial is further branched into three. It is known as synchronous. The second is known as synchronous. And third is as isochronous. What is parallel? Now I have a sender here. I have a receiver here. When I start the transmission, I have an 8-bit wire here. Or I have 8 wires here, sorry. So when I have 8 wires connecting these two, that means that means I would be able to transmit 8 bits parallelly at the same time. This is good. Why? Because I would have a very good speed. But it has a disadvantage that I would have to have lot of wires. This would be expensive. As compared to this, we use serial communication. And what is the serial communication? I would have a single line, but the bits would pass over it one by one. One bit follows another bit. There is only one communicating channel. The advantage may not be the speed. Speed is decreased, but advantage is a reduced cost. Now, based on this, serial communication would have three types. The first one is asynchronous. In asynchronous, timing is not important. Information is received and translated as per some agreed pattern between A and B, the two communicating partners. Now you do use this pattern based on grouping of bit streams into bytes. You have 1 byte, 2 byte and so on, and send them as and when you want to send. There is no synchronization between the two partners A and B. So receiver does not, receivers rather than does not, receiver cannot predict the timing of the group. That's why I said timing is unimportant here. Then how do you alert about start and end? You use extra bit uh, in the packet for an alert. Usually 0 bit called the as start bit and 1 bit as stop bit. Gaps in these can vary and it's a slower method of communication as compared to the synchronous transmission. The second one that we have is synchronous transmission here. In synchronous, you put bits into frames. You combine lot of bits and say that this is a frame. And this frame can contain multiple bytes altogether. Receiver keeps the count of it. In between, you have zeros and ones to show that the communication is idle. Obviously, in synchronous, timing is important. And what do we have gaps here? Unlike in asynchronous, there will be gaps in frames. There won't be gaps in bits. And for isochronous, synchronization fails in audio video transmission. Isochronous generally guarantees that data would arrive at a fixed rate. That's why it would be good for audio video transmission. That's one thing that I wanted to explain. The second thing about point to point, multi-point and point to multi-point, I have nodes here. This is 1, this is 2. This connection is known as a point to point connection, I would say B to B. Next is I have here a node one node connected to multiple nodes. This is point to multi-point. Okay. And then I have a third one in which I have here more than one, on which here also more than one. I can have connections between the two as multi-point connection. Now, why are these important? There are certain terminologies that we'll come across within the networks to understand that uh, what we are talking about. Like for example, if I have a node here and I have multiple nodes here, this is a link. I have a router here. This is R. This is connected to this. Now I want to transmit a signal from the source that is here. I will mention the source here as S, and these will be the destinations. That is the D. Now, if I transmit my signal from source to the router here, and it gets to all of these, like this one is known as broadcasting. What would be the example of broadcasting? The Doordarshan tower that you see on Shankaracharya Hill is a tower that sends out signal, and whosoever has the capability to receive it, means if you have a TV, you can receive that signal. This is known as broadcasting. All right. Now, as compared to this, within this network, there are devices, I will name them. This is A, this is B, this is C, this is D, this is E. When A had sent the signal to all, that is B, C, D, E, we did broadcasting. But now the same network in which A sends a signal to D only, this is known as unicasting, or this is one-to-one communication. There can be third one. It was one to all, that is broadcasting, one to one, that is unicasting. There can be a third condition in which A sends a signal to the router, and then within this network it is sent to only specific devices. This is known as multicasting. This is one to many. This is not one to all. It's like you send a signal, DTH, direct to home. If you have that capability to receive, you would be able to receive. You use video on demand, you will get video on demand. B and D asked for video on demand from A, they received it. C and E could not receive that. This is known as multicasting. Any questions? Okay, I'll complete the functions of the physical layer. There are just two more things that I have to write here about the functions. The next function that we have about the physical layer is whether the communication is simplex, whether the communication is half duplex, or whether the communication is full duplex. These transmission modes are defined by the physical layer. Simplex is on one direction, half duplex is both directions but one at a time, and full duplex would be both can send and receive at the same time. This type of transmission can be there. This is defined by the physical layer. One more thing that we have as auto negotiation, this would be auto negotiation. This would be taken care by Ethernet when we study about Ethernet, in which when the two devices are connected, they choose a common, transmission parameters like speed, what mode are you using, is it half duplex, full duplex, would there be flow control, and so on. This negotiation between the two parties is known as auto negotiation, and this is done by the physical layer as well. All right, I'll end here the class for the theory. We are done with the functions of the physical layer. In our next class, we'll take about examples. We'll see what hardware we come across the physical layer and the transmission media, guided as well as unguided transmission. Let us open the networks lab and see where we have reached. Any questions till now? Najmus Saqib Mahboobi, you have just entered the class when we actually finished it. Normally, if I would have been in the class, what would I have told you? Welcome. Anyhow, let me go to the slides. Next part of it is our networking lab. Ramanan, can you see the
Yes,
slides?
sir. Tracet command.
Okay. Okay. We did tracer, we did path ping, we did this example. Okay, question by one of the students is TJ Ping software. I don't have these kind of softwares in Linux. I said in the lab also that it doesn't matter what software you use. I just want you to look at a software that would give you, a good interface in which you can have a lot of functions like ping, lookup, trace route, and so on. So you can just check any of the softwares that you want. PRTG, whatever monitor you are using, should not be an issue. Don't worry about that. Netstat, also we did that command. Net command. We did add command. This command is used to initiate any activity at a specific time. You can simply say, at this time, run this command. It has a lot of options you can see there as well. You want that during the night, whether the connectivity is there or not, at this time, go open the command prompt, ping this address, ping it 20 times and see what would be the report. It's basically you predefine a certain command you can do, you can use add command. It's also known as scheduling a task, SCH tasks. You schedule a task. Then comes the net command. Net command is an important command in which you have a lot of options like net name, name of the PC, net share the about the resources of the PC, net start a service, net stop a service. Let us go to CMD And within this command prompt, we will try these net commands. Just type net, N-E-T. Everybody open your command prompt, go to CMD and type net. What do you see there? The syntax of this command is net, accounts, computer, config, continue, file, group, help, and so on. So as an example here is given, you can create a shared folder based on this, in which you can write net share and then the details of the folder that you are going to share. Nowadays, we simply go and right click properties, share folder tick, and that should be shared. That's the other way of simple way of doing it. You can create the map drive as well. You can remove the map drive as well. You can delete the sharing option that you have done. You can do that. There's another option in which you can do net send, NETSEND. What it basically does is you can net send if within a lab you are over a LAN, you know the destination IP address, or you know the destination PC name, you can simply write net send the IP address of the destination and then the message that we have here. Net send, the destination name, it's one of the example of net send is given here, and then the message also what you have said. Then we have net name as well. To know the computer names that your computer can be sent to, you can use net name. Moving on to the next command is the route command. Route is an important command in which it can give you a lot of options with respect to networking of IPv4 or IPv6. What is route? Basically, route is a path which the packets would take. If you want to see what is the present route that your computer takes, you can simply use route print. Go to command prompt, write route print and see what is the output. It would first give you an interface list. Is everybody getting this? Yes, okay, right. Something like this everybody would have got, right? So what does it explain here? At first, at the top of route print, you would have got interface list. There is written F4D108 something 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 something. What is it? This is known as a MAC address. That is an address given by layer 2 of OSI. That is the medium access control protocol address given by layer 2. Each device, each interface would have its own MAC address. This we will be studying in our layer 2. At this moment, it is giving the details of what addresses do we have for the interfaces. Then moving on to the next table is IPv4 route table. This we will study in our network layer. Here we have network destinations, the IP address of those destinations, the network mask, the gateway, basically your computer is connected to. Gateway is where all of your traffic goes, and from here it would move out of your premises to the internet. through what interface it is going, and there is a metric given as well. We'll come to all these metrics, netmask, gateways in coming labs to understand in coming class what all this is, what net metrics is, and so on. There are no persistent routes here. You haven't defined any static route here. Every route here is a dynamic route. How does this routing table form? When you started your PC, your internet connection started, you started at you started sending and receiving the traffic. These routing tables started to create. And then we have IPv6 routing table. IPv6 is another addressing method. We will study in network layer why we need IPv6 if we have already IPv4. We'll do the comparison of the two. At this moment of time, keep in mind that here we have IPv6 enabled PC in which there are some links available, but no traffic has been received or sent, no routes have been developed because we did not use IPv6 addressing. We sent all of our traffic through IPv4 addressing. So this is basically a route print command. Now, if you want to see only the route print of, v4 addressing, you can use route print -4. So you'll get v4 tables. Route print -6. You will get v6 tables, only the one which we just now saw. Now, something important here for you is that if you want to specifically add a route to your computer, say no, my traffic should necessarily move through a specific gateway, then you would use route command. How? Write out route add mask gateway metric and then pass on. I'll give you an example here of route add command. And all of your traffic would be forced to go through interface to this IP address. Likewise, you would have this for IPv6. You can alter this what you just now added with the help of a route change command. Again, you would have to change if there is interface route change from this to this. Now you edit this, you do not want this, you can delete the route, you can delete these by using route delete. So simply route delete this one, would delete it. Again, I have shown it. So a lot of options are available with the route command. This command basically manipulates the network routing tables. The syntax is given there: route f command, destination, mask, net mask, and gateway. Don't worry about this net mask. Don't worry about gateway metrics. We will come to all of these one by one. All right. An example is given here of route add. ARP command or ARP command. It's address resolution protocol, ARP. It is used specifically by IPv4 to map IP network address with the hardware address. We have two addressing available in layering that we understand here, the OSI or other reference model. One is the IP address, that is the layer 3 addressing, and one is the MAC address, that is layer 2 addressing. Like you see, you check just now we saw what was the MAC address of. Now, in order to map my IP address with my MAC address, I would need a command which is known as ARP command, ARP command. Let us go to the command prompt and check what ARP does. Type ARP and press enter. I hope Linux and Mac guys, you don't find any issues with those commands. Okay. Now it's given here A. Let's use ARP-A. And you would get a list of interfaces here with the physical address. You have internet address and an equivalent physical address, which is either of type dynamic or static. This is using the ARP-A command. You can delete it, you can add a specific host, and so on using this ARP command. So basic ARP-A would display current ARP entries. In layer 2, we will discuss this address resolution protocol. There you would understand this more. As of now, you try this command and the output would be. Basically, we would have one Ethernet address associated with one IP address. This that you can check from ARP-A. Various options, you can see slide number 23. These options are there. So to display the entries in ARP cache, ARP-A, to delete an ARP entry, ARP-D, delete that IP address. The next command is one of the important commands, that is the IP command. For Linux-based systems, use IF instead of IP. IP config is for Windows, IF config is for Linux. Right? IP config, if you are on Windows, you will see a lot of options there. Typically, if you want to know what is your IP address of the system, what do? IP config. So when I did IP config, I got Windows IP configuration here. LS LAN adapter Wi-Fi 2, connection specific DNS suffix domain.name, link local IPv6 address. IPv4 address here I have because I'm connected to a local router here. I have 192.168.1.9. This is my IP address and this is what I got from IP config. Then I have subnet mask also given here and default gateway for IPv6 as well as IPv4 address. If you see, I'll just copy paste this and put it in the chat. You would also have got something based on what connection you have. If you are on a wired Wi-Fi connection, you will have a local connection given the local IP address given there. But if you are on mobile, you would have a bit different IP given there. It will be a public IP. Now see here, the one which I pasted here. IPv4 address is given here 192.168.1.9. This is the address which is of my PC. And how does my traffic go across? All of the traffic goes through the default gateway, which is given by 192.168.1.1. All right. And there are, lot of other commands which come with IP config. Like, for example, you enable, disable your network interface card. What do? You can just renew the IP addresses. Like you see that your network, you have problem with IP address. You start your PC and somebody in the lab has already taken that IP address and you get an IP conflict. Say, oh no, you restart it and so on. You don't need to do all these things. You can simply go and renew it. What you can do is you can write IP config / /renew then the name of the adapter or the interface you are connected to it, it would renew the IP address. If you want to release the IP address that you have presently, you can use IP config and release. To see the complete details of your network that you are connected to, your interfaces, you can use IP config display all. So use IP config, type IP config and see what the IP config, and then the help of IP config would give you a lot of other examples like IP config all, IP config renew, and so on. Next command is net sh. Any questions till now? If you type net sh in your terminal, it will give you a net sh prompt. Your prompt changes from C user and so on to net sh. And what is this net sh basically? It configures interfaces, routing protocols, filters, routes, and so on. The syntax is given here. You can use like for DHCP, IP, IPX, NetView, and so on. Now, for example, if you are in NetSH, use routing and question mark, or just type question mark without writing anything. It will give you what command you can use. For example, changes to the wireless LAN. You would use netsh WLAN. So type WLAN, you go into WLAN. Type question mark within the WLAN. You getting me? Let me just type here. Type first netsh at the command prompt. You went into netsh prompt. Type question mark. You will get a list of things that you can do with netsh. It's an important command, isn't it? Let's say I use WLAN. I type WLAN there. Now I have netsh WLAN. You should have something like this now. Everybody getting this? Okay. All right. After this, what we have is let me just check. NetSH for Mac. For I'm just checking I'm just googling netsh command for OS. It's sudo arp. Try to Google it. It shows sudo arp. But I believe this would be for things we typically use for Linux. Give it a try. Give it a try.
Sir, screen is not visible.
Okay. Yes, sudo arp works for Linux, but for this Mac, just give it a try. Ramanand, what do you see this time? Nothing?
Something like mesh.
Like?
Mesh. A silver screen.
You can't see the terminal, is it?
Yes, sir. I can't see.
Before this, you could see the terminal?
No, sir.
Oh, never mind. Are you doing? You are opening your terminal yourself, right?
Yes, sir. Yes, sir. No problem.
Yes. So no, should not be. How about now?
Yes, sir. It's visible.
Okay. Before this, it was not visible.
No, sir.
Oh. Anyhow, is it clear now? Can you see what I'm typing?
Yes, sir. Now it's clear.
Oh, okay, fine. Now I am in net sh and WAN. I'll use a question mark and I'll get these options here. With this, I can display the information there, like this one, or what I want to see within the show. I can have delete, I can have add, I can have dump, I can have export. I can even connect to a wireless LAN using the command prompt. You can see here. Connect, I have to use connect, the name of the, like profile one. Then I have to give SSID of that network I am being connected to. Then it will prompt me for a password and so on. So whatever you do with the wireless LAN, you can simply do within this command. So NetSH is a very, if you want to go out from this, just use simply exit. Enter NetSH, get the net prompt, put a question mark, all list of whatever you have. Now, I was talking about net SH, this wireless LAN. You can simply go to LAN as well, and all the options within the LAN you can get. Show, simply show the information that you have within it. Show mode, I am online. Show alias, no network alias here associated with it. Anyhow, let me go back to the presentation. This is about the net sh command. You can do routing, you can do dump of all that you have and so on. There are other commands as well, which is given in the list. Ramanand, do you see the other command list?
Yes, sir. Telnet SSH.
In some commands, yes, like telnet, SSH, they are quite important commands. I'll go back and I'll try to share my terminal. Now you can see my terminal. No, my terminal is not visible. Okay, it's visible. So when I telnet here, it gives telnet is not recognized as an internal or external command. Others you might get this that you have telnet. So for those you do not have, you need to go to the settings, go to Windows features, turn off and on. I repeat, go to settings. Within software where you install softwares, there would be an option for Windows features, turn off and on. Once you go to that, there would be a list of options that are given there, and then within it there would be a telnet client. Okay, I'm sharing now that picture as well. Can you see that, Ramanand?
No, sir. Half screen is blur. I don't know. It's showing some silver.
Can you see turn Windows features on or off?
Ah, yes, sir.
How about others? Anybody? You can see. Okay. Can you see there is one telnet client? Below that there is TFTP. FTP stands for File Transfer Protocol, and TFTP is Trivial File Transfer Protocol client. I have put a tick over telnet client. I pressed OK. It might take some time to install this telnet command. Now, what does this telnet do basically? It would help you in remote logins. Okay. Okay, it's done for me here. I will go back. Now I'm back in the terminal. Can you see me?
Yes, sir.
Now I press telnet and telnet is there. How about others? Repeat. Okay, repeat. Go to turn Windows features on or off. Tick on telnet and it will install telnet on your PC. Okay, once it's installed, you will get a prompt like I am here on Microsoft Telnet. There are a set of options in which you can telnet another PC. I think this is a good link what he has sent. Livewire, what Ritesh has sent. Livewire and how to use telnet on Windows. Okay, yeah, it has given step by step. You can follow there. If you have Windows 10, just write turn Windows features on and off, or simply write telnet in Windows 10 at the search button, and it will give you turn Windows features on and off, and you can generally reach that. And then telnet has a lot of functions. It provides you a virtual environment. You can message others. You can access others' PCs through this. And for example, if I telnet this time, Let me just exit. So I can remotely connect to another device using telnet. I tried to telnet my router here by using telnet 192.168. It's not giving me access here. Typically, when you try to access, okay, if you are asking for telnet server, means you can take requests from telnet clients as such. You install server on your PC, other people can access your PC. If as client, you can let access. After you're done, you just disable the telnet client. You won't generally use it. Typically good for remote login. As of now, just use telnet client. Okay. So you can use telnet for a lot of things. Like you can do editing of files on a server itself using telnet. You can use programs and so on using. It's basically a remote connection. Okay. And whatever you do after remote login, it is up to you. You can ask your friends, IP address, then remotely log using Telnet. Telnet should be obviously enabled on both the server and the client where you are accessing. Right? Then we have the second command which is mentioned there as SSH command. SSH is a secure shell command. It's used to log into a remote machine again and execute commands based on that. It's based on tunneling. Use SSH on a server. You understand this? It's given the log is given here. How you can use SSH run commands on it. You can go to your you can log into your friend's PC and then execute commands on your friend's PC based on SSH secure shell. This is a client server approach. I think we are done with this. Use others as well. Some might be not be available on your PCs, some might be. Now coming to this lab work, there is a long list of things that you would have to try it out to get the know how the so that I get to know that whether you have done it by yourself. Each screenshot should have your name in it. Each screenshot should have no a name in it. How can you put your name? I want like this terminal. You can see my terminal, right? There is C users and there is SQ. So your PC name should be displayed there and put your name as your PC name. This would stop copying of assignments. Each screenshot would have your name. Now if you try to Photoshop, it would take a lot of time. So better just change the name and try these yourself. I'll give you the email where to submit this. I'll just put it here. There will be another email to submit these lab ones and another to submit the theory one. Lab due date would be Friday, next Friday, and Monday I have given you the due date for the theory. Okay, some commands run only in administrator mode. It would depend upon what access, what you have given to your, you know, command prompt. Run them as administrator, or you won't have your name there. In that case, I've given the email address to submit. Most of the commands should work with it. Yes, this is for lab assignment. This is for lab assignment submission. Also, next week I'll tell you that before we move on to the lab 3, what software simulation network simulation software you will install. There are a few softwares like you would have to have Wireshark, we would have to have typical simulations like D-Reverb and Modeler. Any questions? For theory I will give you another email address. Attendance, Ramanand, have you taken attendance of all who were present?
Yes, sir. Attendance is recorded.
Okay, fine. Keep an Excel file and just put,
Yes.
me for them. All right, thank you all. Any questions?
No, sir.
It has been a long session, I understand, but enjoy your weekend. All right. Take care and bye-bye, everybody.